It's elementary mathematics 1.
Okay.
All right. So I can hear you. So we are
Yes,
looking
I'm
at
with
this
you too.
command, okay, through the
Yes.
course material. Through the course material. Okay. Okay. So measurement. So we're going to start with the first one, which is this now. We're starting with this one, which is module 1. We're starting with
Nothing.
this. Okay, so we're looking at set theory. That's the first topic you have: plate, set of spoon, set of cups, and the rest, right? In the market. So people say, I want to buy set of spoon, set of plates, set of pots, set of cups, and the rest. Have you heard that before? Hello? I asked the question. Have you ever bought set of spoon, set of plates, set of pots?
Yes.
Uh-huh. That's what this topic is telling us about, set
Um.
theory. So the question
Okay.
we're going to start with the definition of set. Then we're going to look at some basic terms they use in set. There are some basic
Okay.
terminology they use in set. Yes.
So
So we're
that's
going
the
to start with the
elementary
definition,
theory.
then set theory. Yes. Yes. That's
Mm.
elementary set theory.
Okay.
So we're going to define set. So a board. So I want to define set is defined as the collection. Okay. Set is defined as a collection of distinct objects or items. So you can
Okay.
write it down. Set is
That is
defined
defined.
as the collection of distinct as the collection
Yes. Collection of distinct,
of distinct
distinct.
distinct objects. So you're not seeing my board.
Distinct
Distinct
objects
objects or items.
or items.
Distinct objects or items. Yes. Okay. That is set. So examples of set, we have set of cups. Those are examples of a set. So you can write them down. Example include
Cups,
set of spoon,
spoons,
set of yes, set of pot, set of
plates,
plate, and yes, set of plates. Okay, set of cups. So those are examples of sets. Okay. Are you there?
I'm here, yes. Set of spoons, plates, pots.
Okay. So when they
Yes.
say something distinct, what does that mean?
No.
Yes. Those are examples of sets. So it's a set collection of distinct objects. Okay. What does it mean? Distinct once, no repetition. That's what I mean by distinct. Element in a set listed only once without repetition. That's what I mean by distinct. Element in a set listed only once without repetition. Okay. Distinct mean element in a set repeated only once without repetition or duplicate. That's what I mean by distinct. I don't know if you can please write it down.
Yes. You
Please write it
said what?
down.
Distinct is
I said distinct means element in a set. Elements repeated.
distinct is repeated.
Once element distinct. No, the distincts are elements in a set. Elements
Uh,
in a set.
elements
In a
in a
set.
set. Yes.
Repeated once
Repeated once.
without duplication or repetition.
Yes.
And that's what I mean by distinct. Okay?
Yes.
That's what I mean by distinct. Yes. So when I say set is a collection of distinct objects, I mean those objects, they are just ones. You don't have to repeat it. I cannot
Okay.
say have things like, for instance, now, I cannot have spoon, plate, then spoon again. Are you saying it? You cannot have plate, spoon, then another plate. So it should just be plates.
Once.
Yeah, just once. That's what I mean by distinct objects. Just once.
Okay.
Yes,
Okay.
yes, yes. So next we're going to representation of sets. Representation of sets. How do we represent sets? How do we representation of sets as a new topic, a new subtopic? Representation of sets. Okay?
Yes.
Representation of sets. So sets are usually represented in capital letter. That's how you represent sets. If I want to say a set of spoon, I'll represent it with capital letter. Sets are usually represented in capital letter.
Yes.
That's how you represent sets. For instance, you can have set a capital letter, then you put the set of items. Then you can also have set B. You also put the set of items under set B. So set are usually donated in capital letter.
Okay.
Okay. Yes. So if you go for any set, you see they want to give you any set, that set will be represented in capital. They will not give you the set of things that is there, but the set itself is represented in capital letter. Okay.
Yes.
All right. So next is set notation. These are just the concepts. You need to know this concept before you can solve any question in them. You need to understand all these concepts before you can solve any question in them. Okay.
Okay.
So we have set notation. Set notation. How do you know? How do you know that it's a set and not just a bracket? We have what we call set notation. I say set notation. How do we
Yeah.
notify sets? How do we show that it's a set? Okay. How do we show that it is a set? So sets are usually notified using a particular symbol. Okay. So this is
Okay.
so the set notation is given as the set notation is given as, so this is how you notify set, this is how it's written. So you don't write set like this, not like this. You don't do it like this. Are you seeing the difference?
Okay.
Yes,
Yes.
this is how you notify sets with this sign here, not this. That. So anytime you see a thing like this, you just know that they're talking about a set.
Set.
Yes. So that would take us to type of sets. That would take us to types of sets. Types of sets. Okay. Types of sets. So the first type of set we have what we call finite. Finite. We have what we call finite sets. Finite sets. So what are these finite sets? These are countable sets. These are countable. Things you can count.
Okay.
Things you can count. Countable sets. For instance, can you give me an example of things you can count? Example.
And like you mentioned, maybe chairs, tables, spoons, cups.
Exactly. Those are examples of countable sets. Examples
Yes.
is a set of shares. Set of shares is an example of a countable set. You can easily count shares, right?
Yes. Yes.
Then the second, have you written it?
Yes.
Then the second one we have number 2, infinite. Infinite sets.
Sets.
Infinite sets, yes. What are the infinite sets? These are uncountable. These are uncountable sets, meaning you can't count it.
You can't count. There's something like sand, water.
Exactly. These are uncountable numbers of elements. Uncountable numbers of elements. You just gave a very good example now. We have things like you have things like rice, sand,
Yes.
water, and ham. So these are examples of infinite sets. So you can write any of those things as your example. You can write any
Yes.
of those as your example. Okay.
Yes, sir.
Then number 3, we have what we call empty sets. Empty set. This empty set has another name. They call it a non set. That's another name for it. They call it
Yes.
non-set.
Null
Yes.
set. Something that is not there for.
Yeah, it's not there. It's empty. Hmm?
Null.
It's empty. Yes. So these are sets containing no elements. These are sets containing no element at all. It doesn't have any element at all. I will
Yes.
call, yes, containing no elements or objects. I will call non-set. Okay, are you there?
Yes.
So this size, it has a symbol. It is donated as. How do you know? It's an empty set. So this size, this is a symbol for it. This is a symbol to donate it. That is
Okay.
symbol for empty set. Or you just see the set with no element inside, just like this. There's no element inside. That's how you donate.
Okay.
Yes, that's how you donate a empty set. So when you see anytime you see a symbol like this, either this or this, it means
Yes.
that it represents what? An empty set.
Empty set.
Yes. Or what's the other name for empty set? It's a
Null set.
non-set. Yes. Meaning a set with no elements or object. That's what we call
Yes.
set. So, and once you I want you to note from here is the symbol for it. The symbol for empty set and the definition of empty set is very important. So it's not all the
Okay.
time they call it empty set. Sometimes they call it a non-set. Please pay attention to those details.
Yes.
All these things are very important. We are very important. It's good for you to have all this knowledge before we start taking questions on them. Okay.
Okay. Yes,
Yeah.
sir.
Then number 4, we have what we call universal set. Universal set. Universal set. Universal set. This universal set has a symbol too. This is how the symbol. This is how it is written. They
Okay.
write it like this, or is written like this. So anytime I see a symbol like this, know it's a universal set. So this topic is all about symbols. The symbols are very important. It's all about symbols. Okay?
Yes.
Mm-hmm.
Yes.
Mm-hmm. So the universal set is a set that contains all the elements, all the elements of a set, that contain all the elements of a set.
Yes.
Yes. Please, what is important here? Take note of the symbols. Symbols are very important. They are very, very
Yes.
important. Yes. That's one. So that is symbol for universal set, and that is definition of a universal set. So, like I said, with all this knowledge, we cannot solve a single question on that set. So, you are going to need all this knowledge to be able to successfully solve questions without an issue.
Yes.
Mm-hmm. Okay, is it understood?
Yes, sir.
And that is the symbol for, like I said, the topic is all about symbols. So take note of
Yes,
this.
and
We are going to
we
see
have
something
four
like,
symbols.
and we are going to see something like this later, but not exactly like this. That is why you should take note of what you are saying. We are going to see something like this later, but not exactly like this. Don't what I saw second now with the yellow ink. Take
Yes.
note of that. Yeah. Then number one we have number 5. We have what we called subset.
Subset.
Yes, subset. So if I have two sets right now, maybe I have two sets, set A, then B. Let's assume we have two sets A and B. Okay.
Okay.
You can see this sign I put here. You see this sign?
Yes.
That is the sign for subset. That is the symbol for subset.
Subset. Okay.
Yes, that's the symbol for subset. Okay.
Okay. Yes, sir.
So this one means that A is a subset is a subset of B. That's what it means. Are you saying it? That statement, this statement here means that A is a subset of
Of
B.
B.
Yes. That's what the statement means. A is a subset of B. But what does it actually mean in practical sense? What does it
Oh.
actually mean in practical sense? What it means is that it means that every element in set A can be
Is in set
found.
B. In
Every
set
element
B.
in set here can be found in set B. Every element in
Okay.
set A can be found in set B. So this one means that every element in set A
Can be
can be
found in B.
found in B, can be found. I'm going to give you a typical example now. Can be found in B. Every element in set A can be
Can be
found
found in
in
set
B.
B.
Are you there?
Yes, sir.
Okay, let me give you a typical example of what I mean by that. Let's assume this is set A. Set A, now I told you set is already represented in what? In capital letter. So let's say
Yes.
set A is 1, 2, 3, and 4, for instance. Then set B is 2 and 4. Are you saying it?
Yes.
So if you look at B, what are the elements in B? Can you mention the elements in B?
2 and 4.
Now that 2 and 4, can you find that 2 and 4 in A? Can you see that 2 and 4 in A?
Yes.
Yeah, it's present in A, right? So
It's
therefore means
present
that
in A.
yes, it's present in A, right?
Yes.
So this one means that B is a subset of A, meaning B is part of A. I can see all
Yes.
what B have in A. So B is a subset of A.
Yes.
Is it understood?
Yes, sir.
Okay. All right. So that's the concept of a subset. So
Okay.
we also have what we called number 5. What was also called proper sets.
Okay.
Proper set. It's another type of set. Proper set. This is how it's written. A is a proper set of B. So you can see the difference, the subset and the proper set.
Yes.
Can you tell me the
Yeah.
difference between the subset and the proper set in terms of their representation?
The,
How do we represent?
the proper set, the C doesn't have the underlining under the
Yes.
mark under,
Exactly.
and
It
the
doesn't
bracket is not the same thing as the one in subset.
exactly. So that's what we mean by a subset. So if A, for instance, A is a subset of B, but A is not equal to B. Okay, that's what I mean.
Okay.
Yes. So a typical example is this. A typical example is when you have maybe I have let's assume we have B as 2, 4, 6, 8, and we have A as A is 4, 6, and what? And 8. Are you seeing it?
Yes.
So there's what is different between the two sets now?
It's two because
Yes,
the A has everything the B has, but it doesn't have the two.
does it have the two? So that means that A is a proper set of B. Okay,
Okay.
that's what it means. A is a proper set of B. So means that A is a proper set
Set of B.
of B. Yes. Okay.
Yes, sir.
Then the other type we have number 6, power 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 set. Power set. So the power set is the set of all possible. It is set of all possible subsets of a given set. It is set of all possible subsets of a given set.
Of a given set.
Yes. Mm. Okay.
Yes, sir.
So, for instance, it is given, it is expressed, let me say it is expressed as 2 raised to the power n. That's how you get a power set. It's expressed at 2 raised to the power n, where
Okay.
n represents where n represents the number of elements, the number of elements of a given set. Okay, n represents the number of elements of a given set.
Set. So what is the number of a given set? 2n.
No, 2 raised to power n.
Yes,
That
2
is power n. The n represents the number of elements of a given set. For instance, if I have a set A, for instance, set A is 1, 2, and 4. Okay? If set A is 1 through 4. So how many elements do we have in set A?
3.
Thank you. It means that your n is what? Is
Is
3.
that 3?
Yes. So what is now the power of the set? Power of set now. Power of set. Power set now will be what? Remember, it's given as what? 2 raised to power n.
3. It's power n.
N, which is now 2 raised to power
3.
3. So 2 raised to power 3 is written as 2 times 2 times 2 into 3 places.
Yes.
That's 2 raised to power 3, meaning you have to write 2 in 3 places. So if I multiply both of them, I will have multiply 3 of that, we have 8. So the power of this set is 8. The power of this set is 8. Understood?
The power of the set is 8. You said 2 times 2 times 2.
That's 2, yes. So which is now 8. Power of the set is 8.
So how did
2
you
times,
come about it?
okay, 2 times 2 will give us what? Will give us 4.
4. Okay, 4
Then
times 2 is
times
8.
2
Okay.
give us 8. Yes. That's how we got the power. The power of the set now is 8. So if you have, for instance, if we have maybe set X is X, Y, Z, and M, for instance. How many, and I will also find the power of the sets. Power of sets. Power of sets. So how many elements are we having this time in the set?
We have 4.
4 elements. Means that, simply means your n is what? Is 4. So the power of the set now, P of X now, power of set A now, it gives us 2 raised to power 4. You see that?
Okay.
Which is 2 times 2 times 2 times 2 into 4 places. Are you saying it? So what is 2
Yes.
times 2 times 2? That will give us 16. So the power of the set now is 16.
16.
Yes. But you now understand how we got the 16, right?
Yes, sir. That
It's
2
not
times 4.
2
Yes.
times 2 times, yes. It's not 16. The power of the set is 16.
Okay. So like you wrote the power of the set that is 3, 2n. So if it's 4, you can't write it 2n.
No, you can still write it. I just jumped that step. You can still write it as 2n. Your n is 4 now, which is 2 raised to
Okay.
power 4. I just decided to jump that step. Yes.
Okay.
You can
So
still write it
even
as
if
2
you
raised to
have
power
5 set or whatever amount of set you have, you can still
elements.
write it.
Yes, 2
Yes,
raised to
whatever
power that
amount
number.
of element, you can still write it as 2n, or if you decide, you can write it 2 to the number of elements.
Yes.
Okay. Okay. I get it.
Okay. So this is this is the types of sets that we have, and you need to take proper take a good note of it, a good note of them. It's very, very
Yes.
important. Take a good note of them. So we also have what we called equal sets, number 7. I would call
Okay.
equal sets. I would call equal sets. Okay.
Yes, sir.
So what is equal set? It's when two or more sets have the same equal set is when two or
Almost it.
sets more sets have the same elements. When two or more sets have the same elements, we call that equal set. Okay.
Okay. Yes,
Yes, we
sir.
call that equal set. Okay.
Yes, sir.
Like I said, you need all these concepts to actually understand when we want to start using them now. And you need them.
Mm.
Without all these concepts, we can actually understand set. So if I have example now, if I have a set A as 1, 2, and 3, and I have another set B as 2, 1, and 3. Do they have the same elements?
Yes, but
So,
different
arrangement.
arrangement. Yes.
Yes. So the arrangement does not concern us. What concerns us is that both of them have the
That's the
same
same
elements. Yes. So
elements. Yes.
yes. So we can say set A is equal to what? Set B. Both of them are
B.
equal. Yes, that's what we call them equal sets. So this is what I mean by equal sets. Okay.
Yes, sir.
Write it. Are you there?
I'm here, sir.
Okay. Have you written it?
Yes, I've done that.
Okay. So we also have what we call number 8, equivalent sets. Equivalent
Equivalent sets.
sets. Yes. Equivalent sets. Equivalent sets. This is when two sets. This is when two sets have the same number of elements. You have the same number of elements, but different items, but different
Items.
items. Yes,
Yes.
that's what we call equivalent. So they have the same number of elements, but different items.
Okay.
So what do we mean by that? Let's assume we have set M. Let's take set M for instance. Set M is 2, 4, and 8. Then set N is X, Y, and Z, for instance. So how many elements are in set M?
3.
How many elements are in set N?
3.
Are the items the same? Do you have the same items?
No, they are
Uh-huh.
different.
But the number of elements is the same, right?
It's the same. Yes.
That's what we call them. So equivalent elements. So M is equivalent
To 2.
to N. Both of them are equivalent because they have the same number of elements, but different items.
Okay.
Yes, that's the number of elements, but different items. That's why I call them equivalent elements.
Okay.
Mm. Okay.
Yes, sir.
So we also have number 9. We have disjoint sets. disjoint set. Yes. So ordinarily, what do you understand by the word disjoint? Now, don't relate
Something
it to
that
what,
is,
don't relate it
they
to
are
what we
not
are doing now.
together.
Yeah, exactly. So the same thing is not different from what set mean. So disjoint set is when two sets or more have no elements in common. Have no elements in
In
common.
common.
Yes.
Okay.
Yes, that's what I mean by disjoint sets.
Okay.
So if set A, for instance, is 1, 2, 4, then set B is given to us as 3 and 5. Do they have anything in common?
No, they don't.
Don't have anything in common. So that's what I mean by disjoint sets. Okay.
Yes, sir.
So write it.
I've written.
Okay. I'm coming. A minute, please.
No problem.
So we also have single sets. Also have a single set. Okay. So one is
Okay.
also have a single set. That is number 10.
10.
It should be single
Set.
single set. That single set is it has another name of some people call it siglation set. I know how you want to call it.
Okay.
Singleton. What do you call it? Singleton set.
Okay, singleton. Okay, yes.
Singleton, or it's derived from the word single.
Yes.
It's when it's set has one element. It's when it's set has one element. For
Element.
instance, set X, maybe you just have a 2. So this is what I mean by single sets or singleton set.
Yes.
That's
It's
what I mean by,
alone. It
yeah, it's
has no
just
pattern.
no, just a single element in it. That's what we call
Okay.
single set. Yes. So these are the types of sets we can take. But if there's more, if there's more, I will let you know. If there's more. But for now, these are the types of sets we can take. Okay.
Okay. All
And
right, sir.
then we also have set operations. This is where you need to give, although all the class give your 100% attention, but in this area you need to give 101% attention. Where we are going to now, operations.
Okay.
Yes, operation in sets. And say operations in sets. Operations in sets.
Okay.
So there are various operations inside. In fact, most of it you'll be doing are based on operations. Whatever answer you have in the operation, they might ask you what type of set is that. That's why we did type of set first. So you might solve
Okay.
and have a particular answer. The question might ask you what type of set is this, but it's the operation that will give you the particular type of set.
Okay.
Okay. So the first
Okay.
operation we have is we call it a union. Union.
Okay.
This is symbol for union. It's like a U. This is symbol for union.
Okay.
So remember I told you something earlier that we might see something later.
Yes.
look at it here. I told you we might see this thing,
Yeah,
but can you tell me? Look at it. This one is for the universal set. You can see the
like,
difference. Can you see the difference between the universal set and
and the operation set.
the union? Yes. What is the difference?
The U has that one has something like a backing and L
Yes.
behind U,
Mm-hmm.
but this
Mm-hmm.
doesn't have.
Yes. So you don't mistake both of them as the same. Different.
Okay.
Yes. So what is what is union of set? Normally, union mean two people or more people coming together. That's what I mean by union.
Yes.
It's commonly used in marriage. When two people come together, is what we call union, right?
Yes, sir.
So the union of two sets. So what is the union? So the union, right? The
When
union,
two elements come together, co.
yes, the union of two sets is the combination. Look at the word. Is the combination. Is a combination of all elements of all elements from both sets from both sets without repetition or duplication. That's what I mean by union.
Okay.
Mm.
Is the combination of all
Yes,
elements from
all elements
both
from
sides
both
without
sets
repetition or
from
duplication.
without repetition or duplication.
Yes, sir.
So example, if I should this one means you can write is A union B. You see it? That is A union B. So if you want to, if they ask you to pronounce this thing now, you pronounce it as A union B.
Union B.
Yes, A union B. You see it? A union
A
B. So
union B.
yes, so this symbol for union, right?
Yes,
This symbol
sir.
for union. This is A union B.
B.
Yes. So let's say for instance, if I have set A, remember we said earlier, set is already represented in capital letter. Set A is
Yeah.
1, 2, 3. Then they gave us set B as 3, 4, and 5, for instance. Okay?
Okay. Yes.
Uh-huh. They're now asking us to find A union B. Remember, union mean you combine the two elements, but you don't have to repeat anyone. Okay?
Okay.
So let's just combine them now. If you are combining them, you start from the least number. Who is the least number here, or the smallest number?
1.
I will start with 1. I want to combine all the elements in A and B now. After 1, what do I see next? I will see
2.
2 next. After 2, what do I see
3.
next? Is
3.
3. No, 3, 3. You don't have to say, that's why I say don't repeat anyone. So it is
Okay.
wrong for me to write 3, 3. It's wrong. You say combine all
Yes.
the elements without repetition. So now that we
That's
have 2,
why.
3 there, you
So
just
you
take a
just pick
single
1.
3.
Yes.
Yes. That's why I say
Then we
combine
take
them
4
without repetition. Then we
without
have 4.
repetition.
Yes, we have 4.
Then 5.
And yes, so this is
5.
now your A. Yes, this is now your A union B.
Okay.
And this is now your A union B.
I get it.
You understand it now?
Sir.
Okay, let me give you one to try and tell me what the answer is. If they give you set X as set S is 2, 4, 6, and set Y is given to us as 2, 3, 5. What is now X union Y? Tell
And
me what you have as
you
a Y.
Y
Mm.
will be 2, 3, 4, 5, and 6.
Exactly. Exactly. Although we have 2 there,
2,
you don't
2.
go
Yes.
around
We
to
have 2
2.
in X, we have 2 in Y,
Uh-huh.
so we just
But
pick
just
one.
pick one, yes, to give you your
Yes.
A union. So your X
Y. X
union
union
Y.
Y.
Yes. So
Yes.
the answer to this will just be 2, 3, 4,
4, 5,
5, and
6.
6. Is it not?
Yes, sir.
So that's X union Y. So let's look at another type of operation we have. Is intersection. Second operation we
Okay.
have is intersection. Intersection. This is symbol for it. This symbol for it. It's like N. That's symbol for
Okay.
intersection. Mm.
Okay.
Let me rewrite it for clarity. Purple, just like this. A smooth N. That is
Yes.
intersection.
Okay.
Mm. So what does it mean when you say intersection? The intersection of two sets, the intersection of two sets, okay,
Yes, sir.
consists of only the elements, only the elements, only the element common to both sets. Only the element common to both sets.
Okay.
That's what I mean by intersection. Only the element common to both sets. So let's take, for instance, and that you can see the symbol for intersection, right?
Yes, sir. Smooth N.
Uh-huh. Yes. So if I should write A and B, how will you pronounce this? How will you pronounce it?
The A and B. Ah,
No. A, what does the symbol represent? That symbol we just wrote
intersection.
down. Yes, so pronounce it now. Pronounce everything. That will pronounce it.
I can't pronounce it.
No, you can. A intersection B.
Okay, okay. A
Yes.
intersection.
Intersection
Okay.
B. Yes.
A
A intersection
intersection B.
B. Yes. A intersection B.
Okay.
Mm,
A intersection B.
mm. A intersection B. That's how you
B.
pronounce it. Yes.
Oh,
If I should have this, for instance, how will you pronounce
X
this?
intersection Y.
Yes, X intersection Y. Hmm.
A
S intersection Y. So
Y.
let's take,
Yes.
so it say what is, it say consists of only the elements that is common. It consists of only the element that is common to both sets. What is common to both?
Okay.
Yes. So let's take example, for instance. If I should have example, for instance, I should have set X as 2, 4, and 6. Then we now have set Y as 3, 5, and 6. We now ask you to find X intersection Y. Let's say we cannot have X intersection Y. Okay. So, like I said, intersection is looking for what is common between the two or more sets, right?
Yes, sir.
So let's check the two sets. The first set says set X is 2,
2,
4, and
4,
6.
and 6.
Then
Y,
Y is 3, 5,
5, and
6.
6.
So can you
Okay.
tell me what they have in common?
They have 6 in common.
So we can conclude that our X intersection Y is just what?
Mhm.
Is
6.
6. So what kind of set is this? A set that have one element in it is called what?
1.
Elements. A set that just have one element is what?
That is a union set.
No. If a set has just one element, what is that set called? Under the type of set. If a set has just one element, it's called what? Check,
Intersection.
no, check check the type of set that we have. Under the type of set, check towards the end. We said something about a set that has one element.
Yes, that's what I'm saying.
Check it.
Okay, that's from the first page.
No, under the type of set that we've done types of set now, right?
Yes.
Check towards the last parts of the type of set. We mentioned about 10. So check which of them has one
Yes, I
element.
remember. Is a singleton.
Set.
That's a
Singleton set.
disjoint.
No,
Yes.
it's singleton set.
Yes, single set or singleton set.
Set. That's what I mean
That
by
is only one element.
you can see it has only one element now. So they can
Yes,
ask
sir.
you now, what type of set is this? You just say it's
Okay,
a
after we've
singleton
done the
solution
intersection,
section,
so
and they
when we
cannot
get
ask
the
you.
answer,
No,
so
it's,
it will
that
now
it's only when you are
become a
asked.
singleton. Yes.
It's
No,
only when you are asked.
yes, that's what I'm trying to explain to you.
Yes,
That
yes.
we got the answer in this intersection
Mm,
because they have this similar with X and Y. So the answer
mm,
to find X intersection Y is 6. So that 6 has
mm.
become a single thing.
Yeah, it's singleton set because because it's just one element, right?
It's only one element that is
Element,
there.
yes, yes.
Yes, sir.
They can ask you a
I
question
get
like
it.
that. Yes, okay. So write
Okay.
it. Mm,
I've done that.
okay. Have you written it?
I've done that. Yes, I've
Okay.
written.
Let's try something else. Let's assume we have set A. Let's assume we have set A, for instance. Let's assume we have
Okay.
set A as 2, 4, and 6. Ademola Tijani, if you can mute your mic. Somebody just join us, madam.
Okay.
Yes, Ademola Tijani. That is his name. If you can hear us, you are welcome to the class.
Thank you very
Yes, you are
much.
welcome. Yes, all right. So my name is Kennedy. I'll be the one to be taking you this Mass 101 for lectures. And you have Mrs. Alima Mohammed. We have been doing the class almost over an hour now, if I'm not mistaken. And we are
Yes.
almost ramping up. But if you can be consistent, we'll be doing it like this. I will teach you the course all through to before you write. When you date your exams, you can do
Okay, sir.
revisions and the rest. Yes.
Thank you, sir.
Okay. So we have this our actually our channel is STEMupAfrica. We teach
Okay,
science courses, both statistics, physics, chemistry, maths, further maths, technical drawing, AutoCAD, and computer science courses. Those are things we do here. Yes. So we are actually creating the first topic in your lesson material, which is set theory. And we've done a lot of concepts about it. Maybe later we can send you the link so you go through it and see what we have done. It's very interesting. Yes. So we are currently in intersection, which is a type of set operation. So this is the second example we are taking now. Okay, so just follow through. All right, so let's continue. So let's assume we have set A as this, and we have set B. Set B is now 1, 3, and 5. We now have to find A intersection B. So remember what we said about intersection. Intersection means what is common between, which element is common between both sets, right?
Yes.
Okay. So look at these two sets now. What is common between them?
Nothing is common.
Common. So that means there'll be no element inside, right?
Yes, sir.
So if a set does not have any element, what is that set called?
Okay, we did that.
Yes.
A set that doesn't have elements.
And is called what?
Set notation, right?
Yes. On that type, or the type of set we also did. We have a set that doesn't have.
Empty set. This is not.
So this particular set is what? Is an empty set.
Set, null set.
Yes. Or you can also call it non-set. Or the symbol for it again is this.
Is zero strike.
Yes. So in an objective text, which is what you are doing, you might see it in this form, or you might see it in this form as your empty set.
Okay.
Yeah. So a typical set like this is what we call the empty set. When there's no element in common, we call it an empty set. So this is a typical example now. So our A intersection B now, there doesn't have anything in common. Therefore, it is an empty set.
Yes, sir.
Yes. Is it understood?
Yes, sir. Yes, I've gotten this one. So
you understood this one, right?
Yes, sir.
Okay. So we're going to look at okay. So what we are going to do, based on what we have done so far, maybe should I give you some practice questions to try?
Yes, sir.
Okay. Let me give you some practice question, and based on what we have done so far. Okay. Now just give me a minute. Let me sort out. Let me sort out maybe set of some selected questions. I will write them on the board. Then you just tell me what the answer. Just tell me what the answer is.
Okay.
Yes. Hold on a minute. So let's take the first one. Let's say they gave us set A, for instance. Set A is 2, 3, 5, and 7. And we're giving set B as 1, 3, 5, 7, 9. And we are giving set C as 4. If you say C as 4, 6, 8, and 10. Okay. So we are asked, say, find question 1, A union B. Question 2, A intersection C. Question 3, we have A, B intersection C. So, Ademola, Tijani, let me explain to you what is meant by union? Union means you combine all the elements in a set together, but you don't have to repeat anyone twice. Intersection is what is common between two or more elements. It's what we call intersection. So you can just try it out. So, Madam Alima, you can solve these three questions.
Okay, let me try.
Yes.
A union one, one, two, three, 4, 5, 6, 7, 8, 9, 10. Then A intersection C. Oh, this one is intersection B. 1, 2, 3, 5, 7, 9. And one, okay. 2,
So, Auntie Malaka, I mean, this symbol U stands for union. I believe what union means ordinarily mean when people come together, it's what we call union. That this symbol here means intersection. Intersection means what is common between two things. So those that is common, those are the things to write down. If it's not common, that means you are not writing anything down. So union is combine two elements together. So those things you see there, 2, 5, 2, 3, 5, and 7, those are what we call the elements. 1, 3, 5, 7, 9 is element of B. So when you combine two things together, but you don't have to repeat anyone, we refer to it as union. The intersection is what is common between the two elements. So we call the intersection. So you can just try and see if you can put them together.
B intersection C. 1, 3, 4, 6, 7, 8, 9, 10. Sir?
Okay, I'm here.
Let me see if I got it right. A
Okay, the first
union of B is 1, 2, 3, 3.
A union B, what do you have as the answer?
1, 2, 3, 3, 5, 7, 7, 9.
Okay. What is B intersection C?
B intersection C is 2. No, what am I? B intersection C. 1, 3, 4, 6, 7, 8, 9, 10. 1, 3, 4, 6, 7, 8, 9, 10. B intersections.
Was disturbing. So I
Okay.
want you to recall your answer again. What is your A union B?
A union B is 1, 2,
Okay.
3, 3, 4, 5, 6,
No,
7, 7.
No. I told you now, you don't repeat anyone. You don't duplicate any number.
Okay. Oh, that means it's 1, 2, 3.
If you anytime you are using number. Mr. Godwin, the class. We are doing Maths 101, and we are doing SetTheory, which is the first topic in your. And we explain some concepts. Maybe at the end of the meeting, I will send you the meeting and the lecture. Then you can go through it. But we are running out of time. So, Mrs. Alima, I told you union. You combine these elements, but you don't duplicate
Yes,
or
sir.
repeat anyone. That's what we agreed.
Yes.
You don't duplicate or repeat anyone.
1, 2, 3, 4, 5, 6,
Mm-hmm.
7, 8, 9.
No, there's no 4. We don't have 4 in the set.
Okay,
We don't have 4 in the set.
A union B, ko? It's
A union B,
union
yeah.
B. 1, 2, 3, 5, 7, 9.
Start it all over. I didn't hear the first part you mentioned.
1, 2, 3, 5, 7, 9.
That's A union B. So you combine the 2 elements, but don't duplicate or repeat anyone. So instead of we have 3, 3 there, but don't say 3, 3. We have 5, I don't say 5, I just write only one of them. We have 7,
Yes,
7,
1,
just say
2,
7, don't write.
3, 5, 7, 9.
9. That is union. Yes, that's how you find union. Or that question 2
Yes.
says you find A intersection
C.
intersection C.
A intersection C.
C. Yes.
And they don't have anything in common. So it's going to be a null
non-set.
answer.
A non-set or an empty set or an empty set.
Empty set. Yes.
Then what about the last one? B intersection C.
C. B intersection C is an empty set.
It's also an empty set. Why? They don't have anything in common.
In common.
Right? Yes. That's what make it an empty set. Yes.
Yes.
That is not all yet.
Yeah. Okay.
So we cannot finish the whole thing today. Okay.
Yeah.
So
okay.
if contact, meet contact, and you can join. It's not chemistry courses and other also. And
you said what?
Let us know. I say this class is not restricted to maths alone. We treat physics, chemistry, all the science courses and computer courses also, and GST.
Yes.
We do all those things also. If you want, so if you're interested, just contact us and we set up the class and we do as we always do. Okay.
Yes, like that. I have the computer, chemistry, anatomy. We spoke to her about it's just the monetary aspect now.
I just communicate with her, and I hope you enjoyed today's class.
It's very interesting because we were taught the facilitator taught us. I didn't even understand anything of what he's saying. But now with this your explanation, I know I've understood, and by the time I sit down and find time and go through them again, it shouldn't be that difficult.
No. So that's why we leave room for. Go ahead.
Yes. I said, we are aging, so we are just trying to catch up on some things because of work. That's why we are doing all the courses. Yes.
And that's why I'm taking my time to break them down for you so you understand everything.
Yes, you
Yes.
did well.
Okay.
It's very simple.
All right. So
You did it in a layman way.
Oh, okay. All right.